Hello, chemistry students. Let's do a Boyle's Law practice problem together. A 55 milliliter sample of gas is held at a pressure of 3 atmospheres. What will be the volume when the pressure is reduced to half an atmosphere? Assume the temperature of the gas remains constant. So before we do any math, before we worry about any of that, how can you tell you have a Boyle's Law practice problem if the problem doesn't say Boyle's Law practice at the top? Well, there's a couple ways. First way, when it says assume the temperature of the gas remains constant, Boyle's law is the only one of our 3 gas laws where we're keeping the temperature constant. The other way that we can kind of tell is by just reading and labeling the information the problem gives us. So first piece of information, 55 milliliter sample of gas. So since the unit is milliliters, I know that's a volume. Let's call that volume 1. And it doesn't have to be milliliters. It can be liters, it can be gallons, it can be whatever unit. A 55 milliliter sample of gas is held at a pressure of 3 atmospheres. All right, so there's our pressure one, 3 atmospheres. Again, pressure can be in other units. It can be in PSI. It can be in some strange units, like occasionally you see torr, T-O-R-R. But typically we're using atmospheres. What will be the volume? So we don't know that second volume. What will be the volume when the pressure is reduced to half an atmosphere? So based on the information the problem gives me, I've got pressure, I've got volume, the temperature remains constant. So that's another way that I can tell I've got a Boyle's law problem. From the first video, our equation for Boyle's law, P1 times V1 equals P2 times V2. And before we do any math, anything else, let's make a quick prediction. So we are decreasing our pressure, right? Our pressure is going from 3 atmospheres to half an atmosphere. And what does Boyle's law say? It says pressure and volume are inversely proportional. So if I am decreasing the pressure, inversely proportional means that the volume will increase. So let's write that down underneath. Prediction, volume will increase. So imagine like a balloon going up into the atmosphere. As it goes higher and higher and higher above the ground, that pressure gets less and less and less and less. There's less air pressure. So our balloon is going to expand. It's going to get bigger and bigger and bigger. So we think our final answer, our V2, should be bigger than V1. Well, let's check it out. So when we plug in our numbers, pressure 1, 3 atmospheres, times volume 1, 55 milliliters, equals pressure 2, 0.5, times volume 2, we don't know that. So let's solve for V2. First thing I'm looking at is this left-hand side of the equation. Let's bust out the calculator. 30, oops, my bad, 3.0, not 30, times 55 gives me 165. So on the left-hand side of the equation, we have 165 equals 0.5 times V2. To get V2 by itself, we're just going to divide both sides by 0.5. So again, 165 divided by 0.5 gives me a final answer of 330. So volume 2, 330. Don't forget, include the appropriate unit. Since we're using milliliters for volume 1, let's use milliliters for volume 2. And was our prediction correct? Volume will increase? Definitely. We went from 55 milliliters to 330 milliliters because our pressure decreased. As our pressure drops, our gas particles are going to be able to spread out more, take up more room. So as pressure drops, volume will increase. Hope this helps.